Hello, and thank you for having me here today. My name is Mike Rawich, and I'm one of the co-founders of Galago. And today, I'll be presenting on behalf of Galago and our innovative service offerings in managing big. Specifically, we'll touch on some commercial aspects, including my team's technical services broadly. Then we'll take a look at some of our recent work in the Silverton area up at Silver Lake, and our ongoing work at the Aspen mine and Amy Tunnel to support Ramboll remediation. Lastly, we'll have some broad conclusions, and then we'll have a chance for questions and answers directly after the presentation. So the service that I work for is called Galago, and we're developing the next generation of mine reclamation technology. We're doing this because we understand that mine reclamation as it stands is expensive. It's manual with lots of safety and operational hazards around it, requiring boots on the ground. It's very difficult to track progress over longer timescales, which many years often takes for mine reclamation. And it's also often remote site locations with very limited access, as some of the examples we'll show today. That's really where we come in. Galago is in fact the flagship program for Ramboll's Digital and Innovation Spearhead. Ramboll is a global engineering design consultancy with more than 16,000 engineers and scientists across the world, and they've invested in our technology through their Innovation Accelerator program. This is the company's own startup accelerator, similar to what you would see done for venture capitalists in Silicon Valley or other places. So the first site we'll talk about in the majority of the presentation here is looking at Silver Lake, which is a former ASARCO trust site. ASARCO filed for Chapter 11 bankruptcy in 2005, and they spun out a number of their properties as a bankruptcy trust. The trust as an entity, it's actually an entity with employees, has a primary responsibility to remediate and sell, if possible, all of their properties. All the environmental actions that we perform at Silver Lake on behalf of Ramboll and the Environmental Trust are in consideration of work plans and budgets that have previously been approved by Colorado Department of Public Health and Environment. What a mouthful, sorry. So the site has a number of challenges around it. To begin with, it has very limited access. It's actually at 12,000 feet above sea level, so it takes quite a bit of hiking to get up there. It's 1.5 miles of switchbacks and trails going over a cliff. There's no road that goes all the way up there. And for this past field season, it was really only accessible for about 2 months before snowfall started to block off some of the access ways we typically. There's a lot of historical buildings around the site. This is a picture of Silver Lake back in its heyday, courtesy of the Historical Society. And these buildings are undergoing degradation. This is what it actually looks like on site right now. So there's an aspect of timeliness, being able to get out there and capture the condition of these buildings now before they degrade further. There's also a number of safety closures that were put in by Ramboll and DRMS a number of years ago and the status of those safety closures is relatively unknown because they are difficult to access. Lastly, there's a number of tailings and other environmental conditions that are relevant around the facility that we wanted to document their current status in case the property ever did go to sell or we were required to pursue any other remedial actions moving forward. So our technical solution to this was to use small unmanned aerial systems, or drones, SUAS, to go out, map, photograph, and videograph the entire area. So we had 4 drones that we deployed in the field. We also had ground control, which you can see a picture of me actually capturing ground control with a precise GPS unit across the whole site. And we processed all information together into a cohesive story here, a digital twin, a direct digital copy of Silver Lake area. So what you see on the screen here is an example of what that digital twin looks like, kind of a buzzword these days. But in this case, we've taken more than 1,100 individual images and stitched them together across the site into a single 3-dimensional model. What we're able to do is actually take this high-resolution 3-dimensional model, and you can see the triangles that pop up here are actually the photo points. we can have our crews be able to access this information directly. You click on a photo point and see the picture. And this is the switchbacks leading up to a cliff. You actually have to pull up on a steel cable here to access. So really unprecedented level of site understanding by being able to grab this information. So the hidden challenge, you have all these site challenges, and we have a great technical consideration in place here. The big challenge is data management here. With more than 250 gigabytes of collected and then processed data available, you need a strategy to look at this thousands of images and hundreds of dozens of videos, and be able to provide it in a manner that's actually useful for a dispersed project team like we have here. The majority of the team for this project comes out of our Denver office. However, for certain aspects of the project, we reach throughout Ramboll's global organization to find the right expert to solve the problem. So in order to really release the full power that we need within by using Ramboll as a consultant for our client, we needed a good data strategy. Our solution to this was by using the cloud. The cloud, again, sort of a buzzword, but essentially it's a remote server for storage that you can then access using an internet connection. Through the system we've set up, which I'll describe more in the next slide, we've set up processing capabilities on the virtual machines, so that allows us, as soon as we get our data into that virtual network, we can stitch that data together, begin to perform analysis, and provide it in a format that's usable for others. Being able to push data to the cloud provides the advantage when you're talking about 250 gigabytes that you have extremely high-speed internet moving between one server and another located on the same premises, as opposed to uploading over home internet speeds, which is something I'm sure all of us have experienced over the past several months with quarantine measures in place. We combined all of these cloud-based processing with some endpoints here for our data, which would be ArcGIS Online, which provides us the ability to bring all this data together in a geographic format, which our project team can then access, and then Azure Storage for the long-term storage of a large volume of our data. So here's a diagram of how we actually move data through this process. It begins by looking at a regional LiDAR set, which was captured in the Silver Lake area several years ago. We take that regional LiDAR and we create automated flight plans, again using different software options here. The two that we put together for safety and automated control to drone, or drone deploy, and skyward. These two actually keep the drone from slamming into a cliff face in conjunction with the LiDAR data. So we go out, we use this automated flight plane to collect this over 100 gigabytes of raw data, and we directly download that to cloud storage, as shown by the center icon. Having in cloud storage means it's off of our computer, it's off of our desktop. There's no worry that you're going to drop your computer in a body of water at some point. Terrible horror stories from somebody on this call, I'm sure, about that. Or lose the data another way. It's secured on Microsoft's Azure virtual machines and in their storage capacity. And as it's on the virtual machine, we're then able to quickly upload this information and process it, then manipulate that data going forward. And the way we manipulate it is by bringing the data through the cloud environment and directly integrating it with some proprietary software that Ramboll has developed, Esri, which is a GIS mapping software, and then long-term data storage as well. The result of this is that you can take all of this drone data, over 100 gigabytes, 250 gigabytes with all this processed imagery in it, and you can make it more than pretty pictures out of drone imagery. You can actually turn this into actionable insights and information and data that you can use for your project. So this is an example of what one of these endpoints looks like in the Esri software. As you can see here, this is a web portable mapping application. So all of this data is geographically integrated. We can take multiple data streams and put them together. So videography, static photography, historical imagery, all this information we have about the site. And what you're seeing here is panoramas, which you can navigate through, similar to what you do on Google Street View. We could take all this together, put it into a web mapping application, and anyone with an internet access can now see this data basically on demand. And we can use this for intelligent site planning activities. In the COVID era, this has proven extremely useful because our project team, should they need to go out and do something on a project like this, can now jump in. And if you have one person who's an expert working in, let's say, Washington, D.C. or Finland, and the rest of the team is in Silverton or Denver, they can look at the same data at the same time, know it's authoritative, and access the full power of that data. So there's massive amounts of data and information that are available to this remote team of experts. And perhaps one of the most useful things about this, or one of the best things that might come out of this, is we're looking to make this available, working with Mark Rudolph and Anthony Edwards, make this available as a community resource documenting the conditions at Silver Lake, in addition to the practical and technical aspects that we care about. So that wraps up sort of the intro to my team, what we're doing at Silver Lake. And I just wanted to briefly touch on some of the other ongoing work that we have. In the next phase of work for the Asarco Trust that my team has been involved in is over at the Amy Tunnel and Aspen Mine, further down in the valley. And as you can see here, you've got the Animus running by and Silverton in the background. And no, that's not a bird, not a plane, or an unidentified flying object. It's actually a laser or LiDAR scanning drone that we deployed just a few weeks ago. And that drone was used to collect very high resolution vegetation penetrating elevation scans of the Amy Tunnel and Aspen Mine area. So we're going to use this data to further analyze superficial flow patterns in conjunction with other remedial efforts that were recently instilled in this area during the past summer. And I think David Hines gave an update of that at the last CAG meeting. Also, we'll be able to provide accurate topography data for future remedial planning, in addition to looking at how it interacts with our current remedial design. So in the words of one of our clients, we are now swimming in oceans of data. We have more ability to collect data than we ever have been able to before. And this provides both opportunities to analyze our sites like we've never done before, but it also comes with a new set of technical challenges that requires unique experience to overcome. Thank you for your time, and I think now we'll open up for questions.